Lesson number 6 continues on factoring trinomials. Only in this case here, the trinomials that we factor will have a number or a coefficient in front of the x squared other than 1. So there are three ways, I guess, that we will look at factoring these types of trinomials that we will work on today and probably maybe even just finish up tomorrow. I'm not sure how long it'll take us to go through it in this class. This is, like I said, with the factoring stuff becomes very important because we factor throughout grade 11 and grade 12 in the further math courses. So this is something that you need to get a grasp on. You need to practice it. You can't do 3 questions and call it good. You have to do multiple questions to establish that patterning, to just make it so that it flows and it's easier to do each time. So what I would like you to do, first of all, is I would like you to expand the 2 binomial products. 2x plus 1 times 3x plus 4, what does that equal? And 3x minus 2 times 4x plus 3, what does that equal? Okay, so what is 2x plus 1 times 3x plus 4 equal to?
6x squared plus 11x plus 4.
Which means that 6x squared plus 11x plus 4 would factor down to 2x plus 1 times 3x plus 4. Okay, someone else give me what is the product when I multiply 3x minus 2 by 4x plus 3.
12x squared plus x minus 6.
Which means 12x squared plus x minus 6 would factor to 3x minus 1 times 4x plus 3. So now we're asked to consider the following problem. I have a polynomial that is 2x squared plus 7x plus 6. What we need to do is we need to consider 2 binomials that when I multiply them together, I'm going to get this product. So we are going to do this with using algebra tiles. So if we look at class example number 1, what polynomial would represent this drawing?
2x squared plus 7x plus 6.
So I'm going to give you algebra tiles, and what I want you to do is take those algebra tiles and arrange them into a perfect rectangle. So how did you go about arranging your tiles to form a rectangle? What did you start off by doing? Okay, so put the 2 big ones together. Does it matter if I put them side by side or if I stack them? Okay, then what did you do? Well, if you remember when we were doing our binomial products last time, we have our x squareds, and then we had our rods kind of fitting around it, and then we always put these guys kind of on the end like that. So if I was to start off by putting one of these guys, I would have to have an x and an x, and then this one I would need to turn and put it that way. Does that stand to make sense? So then if I wanted to put another one like this, I would need 2 more of these. And then if I took one of these and flipped it, or actually, sorry, so I only have 2 left, which means if I went like this, I could only put 1 more of these in there. So that's not going to work, because now I have 3 left over. But if I flipped this and went this way, do I have room to put these 4 in there now? So the big thing to establish when I'm using my algebra tiles is how I actually set this up. So I'm not trying to make a frame or anything. It's very systematic. I put my x squareds and then my rods kind of surround those x squareds, and And then these ones kind of go kitty corner to my x squareds. Okay? So now that we've established that rule, would it make it easier to use algebra tiles for the next questions? Okay, so now if we go back on this, we're going to draw this shape in that space here. So we had an x squared and an x squared, and then I had two rods. Make those skinnier to make them look like an actual rod. And then I had 3 rods, 2 more right here. So there's my 7 rods. And there were my 6 little tiles. So now if I look at length and width, what would be the length of this side? X plus 2, because this length here is an x, and these are 1s. So this would be an x plus 2. And what would I have along the bottom? So if I was to use this diagram to express my polynomial of 2x squared plus 7x plus 6 in factored form, I would have 2x plus 3 times x plus 2. So now if you look at the next page, class example number 2, I want you to factor this one. 5x squared plus 7x plus 2. So when I started this one this time, what did you notice about when you start putting your x squareds together to get your 5x? Could you put them, because I noticed a lot of you started off this way. Can I do that?
No.
Why not?
Because of reasons.
X squared open.
Okay, but can I just fill the x squared up with this?
No, because it's not actual.
And this is done on purpose. The algebra tiles were specifically designed this way. If I try to line these tiles up, they do not fit in x squared exactly. And it's on purpose because they're not equal. Okay? So if I can't line them up in this configuration, it must mean that I have to go this way. I'll move that out of the way. And then what do I do with all of these rods afterwards? Okay, so I start putting them along the bottom. And I have to put them along the bottom because that's the only way that I can get a 1 here, is I have to be able to put them along the bottom.
Means that one has to be on this side.
Which then means I need one along the top.
You put one on the cover.
Okay. Draw that figure in that space for class example number 2 if you haven't already done so. So I would have 5x squareds that are lined up side by side. And then I have the 5 rods that went underneath. And then the 2 that went vertically so that I can have my 2 tiles on the end. Okay? So what are the dimensions of this rectangle? What's the length?
5x plus 3.
There's my plus 2 and my 5s. And what is my width?
X plus 1.
X plus 1. Okay? So what I would like you guys to do now is I would like you to practice by doing question number 2. So when I use algebra tiles, I can factor these trinomials and I can get my binomial products. What is the disadvantage to this system?
It's tedious, and then if it gets too big of numbers, you don't have
Takes up a lot of space.
Same thing we said the entire chapter.
Same thing that we said when we were factoring the trinomials last time. If I have 12x squared, I now need to put a couple of packages together because I don't have enough of these big tiles, and it's tedious, it's time consuming, it takes a lot of work. So we want to move past having to use algebra tiles, and we want to find an algebraic solution to factoring these. So there are two ways that we can factor. The first way involves that grouping method. We talked about factoring by grouping in at the beginning, I think it was lesson 2. So when I said you have 4 terms, I could probably group the terms together. If I look at 6x squared and 3x, what do they have in common?
They're positive.
Pardon me?
Yeah.
3x. So if I factored out or removed or divided by 3x, what would that leave me with?
2x.
Then if I looked at my 8x plus 4, what do they have in common? 4. So if I remove the 4, factored out the 4, what would that leave me with? 2x plus 1. What do I have now? I have a binomial because I only have 2 terms. Do I have a common factor within those binomials?
2x plus 1.
So I could remove the 2x plus 1, and that would leave me with a 3x plus 4. And by the way, this 6x squared plus 3x plus 8x plus 4 was my 6x squared plus 11x plus 4 that we had at the beginning of the lesson. So now if I look at my 12x squared plus 9x minus 8x minus 6, finish this up for me. Factor by grouping to determine what my 2 binomial products would be. So if I finish this by grouping, what would I remove out of the first 2?
3x.
Which would leave me with? And what do I remove out of the next 2? Negative 2, which would leave me with?
4x plus 3.
So the goal is to try to get a 4x plus 3. That's why I would remove the minus 2. So I'd be left with 4x plus 3 times 3x minus 2. And again, this was on the previous page. That was that 12x squared plus x minus 6. So if we look at this 6x squared plus 11x plus 4x, when we went to factor it, we split up the 11x into 3x and 8x. Why did we pick 8 and 3? For 11x, I could have had 10 and 1, 5 and 6, 7 and 4, 9 and 2. There's multiple combinations that would have given me the 11x. Why did I choose the 3 and the 8? The same thing with the other one. Why did I choose 9 and negative 8 to express this positive 1? I could have used 3 and negative 2, 5 and negative 4, 10 and negative 9. But there, again, there's multiple combinations that would have given me this 1x other than just 9 and negative 8. What makes those combinations so special? Any ideas? Brianne.
Because they're common, so up there, 6x squared, that's common to 3x, and 8x is common. So you can take out a common factor.
Okay, but if I went 9 and 2, would that have not worked? Because 9x would have been common with 6,
Yeah.
and 2x would have been... So why this 8 and the 3? Well, when we looked at In the review part 1, how are the numbers 8 and 3 connected to 6, 8, and 4? So let's start off with, not 6, 8, and 4, 6, 11, and 4. That would make more sense. How are the 8 and 3 connected to 11? Okay, so we have that one. 11 was equal to 8 plus 3.
Is it sum and products?
Sum and products?
Yeah.
So how would the sum and products work this time? So I have the sum,
Yeah.
but what would my product be this time? So what's my product? 8 times 3, which is?
That's 24.
How does that relate to my 4 and my 6?
4 times 6 equals 24.
So I still have that idea of sum and product. Only this time my product is not just the last term. It includes what?
Your x squared.
The x squared term. It also includes that first term. Does it work for the 9 and the negative 8? What's 9 plus negative 8? 1. That's my b value. What's 9 times negative 8?
72.
And does that equal 12 times negative 6? So my sum and product still works. What I need to remember is when I'm doing my product this time, I need to have A and C multiplied together. And that A times C is actually not new. What would my sum and product this time be?
7 and 1.
My sum would be, no,
Or 7.
my sum would be 8. And what would my product be? What's the coefficient in front of the x squared?
1.
So can I still put 7 times 1? Yeah. Multiplying the outside numbers together to get my product still works in what we did before because the number in front of the x squared was 1. So in a sense, I ignored it because 1 times 7 is just 7. I don't have to worry about it. But when I put a number in front of the x squared, now I do have to worry about it. So in class example number 3, we are going to algebraically factor what we did in class examples 1 and 2. So we're going to use this sum and product chart again. Sum and product. In this one, what does my sum have to be?
7.
What is my product this time? 6 times 2. So 12. So now answer the question. What are two numbers that multiply to 12 and add to 7? 4 and 3. So what we're going to do, because this is called decomposition, so we are going to start off by rewriting 7x as a 4x and a 3x. Is this equation that I just wrote, or expression, is this expression the same as the original expression? I just changed what 7x looks like. If I group these two terms together, what can I factor out?
2x.
And what would that leave me with?
X plus 2.
And what would I factor out of these two terms?
3.
And what would that leave me with?
X plus 2.
So I have x plus 2 times 2x plus 3. Does it matter if I put 4x plus 3x or 3x plus 4x? Well, let's try. You don't have to write this part down, but just watch. If I went 2x squared plus 3x plus 4x plus 6, what do these two have in common? Just x. So what would I be left with if I factored out an x?
It's gonna be large.
What do these two have in common? And if I factor out a 2, what am I left with?
2x plus
So 2x plus 3 is common to both terms, leaving me with x plus 2. Does it matter? No, because I will still end up with the same binomial products. However, when we go to write them in, where would we be more likely to put the 3x with? We would probably link it with the 6 because we should recognize that 3 and 6 are going to have something in common. If it looks like they don't have anything in common, no, it means that they still have at least one thing in common. What do they always have in common? 1. But if I take a 1 out, does it change anything? No, but sometimes it's necessary to take a 1 out. Okay, so if I look at this 5x squared plus 7x plus 2. Again, we do sum and product. What is my sum? 7. What's my product?
10.
Pardon? 10. So two numbers that multiply to 10 and add to 7. 5 and 2. So when I go to write this out, where do I want to put the 5x? First or second? First. So 5x squared plus 5x plus 2x plus 2. So what do I factor out of the first two?
5x.
What does that leave me with?
X plus 1.
What do I factor out of the next two?
2.
Which leaves me with,
X plus 1.
so my final binomial product, x plus 1 times,
X plus 2.
which is what we got when we were using the algebra tiles for part 1 and 2. Okay? I want you to try to do class example number 4 on your own. So I'll give you about 5 minutes and see where you're at, and then we'll look to the next part. So if I look at 4a, what does my sum have to be? My sum has to be 17. And what does my product have to be? Negative 18. So we talked about this before. In order to have a negative product, what do I know about one of my numbers?
One of them has to be.
One of them has to be negative. So then when I'm finding my factors for 18, I would find the difference to get my sum. So two numbers that multiply to negative 18 and add to a positive 17. 18 and negative 1. So we talked about this before. It doesn't matter which one I put where, but if you were to write this out, which one would you group the 18x with? 6x. So 6x squared plus 18x minus x minus 3. So now if I look at the first two terms, 6x squared and 18x, what do they have in common? So if I factor out a 6x, what does that leave me with? So when I go to factor in the next two, what do you think I want to end up with?
X plus 3.
I want to end up with an x plus 3. So what do I need to remove from both of these?
Negative 1.
A negative 1. Negative x divided by negative 1 would leave me with a positive x. Negative 3 divided by negative 1 will leave me with a positive 3. So now I have an x plus 3 that's common, leaving me with a 6x minus 1. And I can do a quick check. X times 6 6x gives me my 6x squared, negative x, positive 18, there's my 17x, negative 3. So let's look at B. What's my sum?
Negative 2.
What's my product?
Negative 24.
So what are two numbers that multiply to negative 24 and add to negative 2? Negative 6 and positive 4. So which one do I want to group with the 3x squared?
Probably the same.
Probably the 6. So 3n squared minus 6n plus 4n minus 8. So what would I factor out of the first two terms?
3n
And what would that leave me with?
and minus
And what would I factor out of the next two terms?
4
Which would leave me with?
and minus.
And again, the goal is to make these the same. And what you guys are doing right now, they should be the same. If they're not, make sure that you need to take out a positive or a negative. Sometimes you have to take out the negative. So I get n minus 2 times 3n plus 4. Okay, so if I look at the last one, what's my sum?
Negative 8.
And what's my product? Positive 12. 12 times 1. So if my product is positive and my sum is negative,
It has to be a negative times a negative.
it has to be a negative. So two numbers that when I multiply them together I get 12, and when I add them I get negative 8.
Negative 6 and negative.
So which one would I pair with the 12x squared?
Negative 6.
Okay. So 12x squared minus 6x minus 2x plus 1. So what would I factor out of the first two?
6x.
Which would leave me with,
2x minus 1.
so what am I trying to end up with in the next one?
2x minus
So what would I factor out? Negative 1. Because that will make the negative 2x positive, and it'll make the positive 1 negative. So I get 2x minus 1 and 6x minus 1. What do you notice about class example 5A?
It's written backwards.
It's backwards. Leave it backwards. Leave it like this. Don't put the negative 2y squared out in front. That's just going to mess you up. What's my sum?
7.
Negative 7. What's my product? Positive or negative?
Negative.
Negative 30. So give me two numbers that multiply to negative 30 and add to negative 7.
Negative 7 and 3.
Negative 10 and 3. So which one do I want to group with the 15? 3, okay. So this would be 15 plus 3y minus 10y minus 2y squared. So when I go to group the 15 and the 3y, what can I factor out of each of them? 3. And what am I left with?
5 plus 1.
5 plus 1y, or just y? And what can I factor out of the negative 10y and the negative 2y squared?
Negative 2y.
Negative 2y. And does that leave me with a 5 plus y? Yes, it does. So then I get 5 plus y and 3 minus 2y. So when the y squared is in the last place, especially when it's negative, just leave it there. Because if I had to put it out in the front, it would just start to become messy. Because in order to get that negative y squared, one of the y's had to be negative. Okay, look at the last one. What do you notice about the last question? product's really big?
They're also all divisible by,
They're all divisible by 5. So what could I start off by doing?
divide them all by 5.
Divide them all by 5. So I would factor out a 5. And what would I be left with?
3k squared plus k minus 2.
So now that I've factored out a 5, when I do my sum and product chart, I only look at what's inside the brackets. So my sum would now be what?
1,
And my product?
-6.
A lot better than 5 and negative 150. So two numbers that multiply to -6 and add to +1. And which one would I group with the 3k squared?
3.
So I'd have 3k squared plus 3k minus 2k minus 2. So what can I factor out of the 3k squared and the 3k? 3k. And what does that leave me with? k plus 1. And what can I factor out of the next two terms? And what does that leave me with? So k plus 1 is common to both. 3k minus 2 is what is left. And the 5 stays to the outside. Okay, class example number 6 for the factoring of these trinomials looks at what happens if I have a variable or if I have two different variables. So we start off by using the same method as before with our sum and product and our decomposition. So in class example number 6, what is our sum going to be? -5. And what is our product? 4. So I need two numbers that multiply to a +4 and add to a -5. -4 and -1. So when I go to rewrite this time, I would have a 2x squared minus 4xy minus xy, because this together would give me my -5xy plus 2y squared. And then my decomposition, I group the first two together. What's common to 2x squared and 4xy?
2x.
And if I remove a 2x, what would I be left with?
X minus 2y.
Okay. And what's common to xy and 2y squared? Okay, and would I take out a -y or a +y? I want to take out a -y because I want this -xy to become positive, and my 2y squared would then become -2y. And then I have that common factor of x minus 2y and 2x minus y. And finally, the last example, I have my sum and product chart again. My sum would be,
-7.
and my product?
-30.
So if my product is negative, I know that one of my numbers has to be positive and one of my numbers has to be negative. So then what I would be doing this time is I would be finding the difference between those two factors to get my 7 or -7. So what answers the question, two numbers that multiply to -30 and add to -7?
Positive 10. Or negative 10
-10 and +3. So which one do I want to group the 10 with?
2.
Okay? So 2n squared. And this time, even though I tell you to write them alphabetically, because it was actually written as 7nm, we'll keep it nm. Plus 3nm minus 15m squared. So what is common to my first two terms?
2n.
And if I remove the 2n, I would be left with
N minus 5n.
and what is common to 3nm and negative 15m squared?
3n.
3m. Positive or negative?
Positive.
And if I've done this correctly, my goal is to try to get what was in the brackets the first time. And does that happen?
Yeah.
Yes. So n minus 5m is common to both terms, and I'm left with a 2n plus 3m. So the questions that I want you to work on: 3a, c, e, and g, 4, b, and c, 6, c, and d,